Hello children, today we will be going to the next part of the water. We will be covering the topics hydrated and anhydrous substances, water of crystallization, then properties like efflorescence, deliquescence, hygroscopy, and drying and dehydrating agents. Hydrated and anhydrous substances, substances which contain water molecules along with salts, like sodium carbonate decahydrate, that is sodium carbonate .10H2O, and copper sulfate pentahydrate. There are many, I have just given two examples. These are called hydrated salts. Now crystals of some salts contain water of crystallization. This water is responsible for the shapes of the crystals. In some cases, it also gives colors, like in case of copper sulfate 5H2O, you will get the blue color. Once this water will go off, you will get the white color. So thus such type of salts are called hydrated salts. But crystalline shape of a substance is not necessarily the result of presence of water of crystallization. That means that for any crystalline shape, it is not mandatory that there should be water of crystallization. Like examples like salt, potassium nitrate, this is sugar, C12H22O11, potassium permanganate, ammonium chloride, etc. These are the substances which do not contain water of crystallization, but they have crystalline shape. These are some more hydrated salts which are containing water of crystallization, like this is washing soda, next is Epsom salt, then Globus salt, then blue vitriol, then this is white vitriol, then this is green vitriol, this is more salt, gypsum and plaster of Paris. Now what is water of crystallization? It is the fixed amount of water molecules that are associated with some compounds which is integral part of their constitution is called water of crystallization. So the water of crystallization is in loose chemical combination with the salts, that is which are hydrated salts. Now these salts lose their shape as well as the color as water of crystallization is lost at around more than 100 degrees Celsius, and such salts are called anhydrous salt. So now the vapors are produced when you are heating, and those vapors are condensed. So you are getting a liquid, and that liquid is formed, whatever is formed, that is tested. The liquid gives test of water. So this you get the anhydrous salt by heating the hydrated salt where water of crystallization will go away. Let us see this example. There is one experiment in your book to show that hydrated copper sulfate crystals, that is blue vitriol, contain water of crystallization. So you take some, it's a very easy example, take some powdered copper sulfate crystals in a clean dry test tube, then clamp it in a tilted position. So it is a tilted position is shown here, so that you can have the condensed vapor. So here the vapors are condensed, so that you can have the condensed vapor, and this should not flow back to the salt. Now the salt is gently heated. So you will get the drop of colorless liquid condense on the cooler part of the test tube, leaving behind a residue. See, this white color residue have started. So this is anhydrous, that is without water, and amorphous, that is non-crystalline. That is non-crystalline or amorphous are those which have no definite shape or structure. So you get hydrated copper sulfate. When heated, you will get anhydrous copper sulfate, and when this is cooled again, it will absorb moisture and becomes blue color hydrated copper sulfate. Now the liquid you get, that can be tested by again adding the copper sulfate in the liquid. You can do this, or this liquid is neutral to the litmus paper. If few drops of this liquid added to the white anhydrous copper sulfate, you will get a blue patch. So you can show that the liquid is water. Also, this liquid turns blue cobalt chloride paper pale pink. So this proves that this liquid which is obtained in the above previous experiment is water. Now how do you determine this water of crystallization? Take a known weight of crystals in a china dish. This is the china dish photograph. Heat above 100 degrees Celsius. As and when the weight of the residue becomes constant, stop heating. Weigh the dry substance. Let's say weight of crystals at room temperature was A gram. Weight of residue after heating is at 101 degrees Celsius is B gram. So water is A minus B gram. So now you say A gram crystal contains A minus B gram of water. So percentage of crystallization is A minus B by A into 100. Now you should remember that during the preparation of crystals of a hydrated salt, we should be careful not to heat them too strongly for drying them. Otherwise the product will be a dehydrated powder, not the crystal. The heating should be gentle heating. Now come to the anhydrous substance. A substance is anhydrous if it contains no water. Example, salt is lacking their water of crystallization. So the term anhydrous is most often applied to crystalline substances when water of crystallization is removed. Anhydrous can also refer to the gaseous form of some concentrated solutions like ammonia, where ammonia is the anhydrous form of aqueous solution of ammonia or ammonium hydroxide. Now anhydrous solvents are also used to perform certain chemical reactions which cannot proceed in presence of water. Now there are some anhydrous substances, example like table salt is anhydrous sodium chloride. Gaseous HCl is anhydrous, gaseous hydrogen chloride. Now anhydrous salts can be obtained from the hydrated form by removing the water of crystallization by direct heating, heating in dry and hot air, heating under vacuum, and using dehydrating or desiccating agent like concentrated sulfuric acid. So we will be going through in details. Now heating and dry and hot air. Why? Because there is a capacity of the air, if it is dry and hot, to collect the water. It has to hold the water. So if you have a dry and hot air, we will be getting the the hydrated salt will be more easily dried and form into the anhydrous salt. Then there is a term called decrepitation. What is that? Salts like NaCl, KNO3, then sugar C12H22O11, potassium permanganate, ammonium chloride, these do not contain water. So to study the action of heat on these type of salts, there is a experiment in your book where they have heated the crystals of sodium chloride and potassium nitrate. If you heat the crystals of sodium chloride, it produces a crackling sound, and this is called decrepitation. This is due to the breaking of bigger sodium chloride crystals in the smaller one. On the other hand, if you heat the crystals of potassium nitrate, it will first melt into a colorless liquid, and then if you further heat it, it will produce oxygen, and oxygen, you know how to check, it rekindles glowing splint, and now you will get a potassium nitrite, which is a yellow colored liquid. So there is a color change also from white to yellow. Now here both the substances like NaCl and KNO3, both they do not contain water of crystallization, and same for other three: sugar, potassium permanganate and ammonium chloride. Now come to efflorescence. It is a phenomena where a compound loses its water of crystallization on exposure to dry air. This results in loss of crystalline shape and finally crumbling of crystals into a powder. And the substances which show efflorescence characteristics are called efflorescent substances. Now here some substances lose wholly or partly their water or crystallization when the crystals are exposed to dry air even for a short period of time. Now when there is a vapor pressure of the hydrated crystal exceeds atmospheric vapor pressure, then efflorescence occurs. So efflorescence can be minimized when there is the humid condition. So higher the temperature and less moisture in the air, higher will be the efflorescence. So if you have low temperature and more moisture in the air, lower will be the efflorescence. So the examples, first example is washing soda. When washing soda is exposed to dry air, it gives sodium carbonate monohydrate and plus 9 molecules of water. And then globus salts, this is sodium sulfate decahydrate. When this is exposed, then it will give a powdery anhydrous sodium sulfate. All water molecules will go off. In case of Epsom salt, MgSO4 heptahydrate, so it gives MgSO4 monohydrate. So higher the temperature of the air, higher is the efflorescence. Why? Because the air absorbs more water with rising temperature and decreasing moisture. Then come to deliquescence. Certain water soluble substances, when exposed to the atmosphere at ordinary temperature, absorb moisture from atmospheric air, become moist, lose their crystalline form and dissolves in the absorbed water, forming a saturated solution. This is the difference. In case of efflorescence, it is loss of water. In case of deliquescence, it dissolves in the absorbed water. These type of substances are called deliquescent substance and the phenomena is called deliquescency. So the examples are potassium hydroxide, sodium hydroxide, magnesium chloride, zinc chloride, iron chloride, zinc nitrate, calcium chloride, copper nitrate. It occurs when the vapor pressure of the salt is less than the atmospheric vapor pressure. Whereas efflorescence occurs when the vapor pressure in the hydrated crystal is more than the atmospheric vapor pressure. So deliquescence is minimized during dry condition, whereas efflorescence can be maximized in the dry condition. Now table salt turns moist and finally forms a solution on exposed to air. Pure sodium chloride is not deliquescent. Now the commercial version of salt contains some impurities like magnesium chloride and calcium chloride. Magnesium chloride and calcium chloride, you have just now found that these are deliquescent substances. So these absorb water and the table salt turns moist. Especially you find this case in the rainy season. Now these type of impurities can be removed by passing dry hydrogen chloride gas through a saturated solution of the affected salt. So pure sodium chloride will be precipitated, which is recovered by filtering and washing with distilled water and followed by alcohol. Alcohol absorbs all water and the sodium chloride becomes totally dry. Hygroscopy. Certain substances absorb water or water vapor from the atmosphere when they are exposed to it, but not enough to form solutions. So deliquescent, it also absorbs water and it forms solution, saturated solution, whereas hygroscopic substances do not form solution. Examples: concentrated sulfuric acid, phosphorus pentoxide, calcium oxide, silica gel, etc. These substances are used to remove moisture from the gases in the laboratory. This is the difference between deliquescent and hygroscopic substances. Hygroscopic substances have a tendency to take up moisture from the air and they can be in solid or liquid state. Concentrated sulfuric acid is liquid, others are solid. These are the differences between drying agent and dehydrating agent. So let us see what are these. Drying agents are substances that can readily absorb moisture from other substances without chemically reacting with them. These are also called desiccants or desiccating agents. So whereas dehydrating agents are the substances which can remove even the chemically combined water molecules from the compounds. So if you see the differences, you will find that dehydrating agent remove chemically combined elements of water in the ratio of 2:1 from a compound. This is the ratio of water, hydrogen and oxygen in the water. Now drying agents are used to prepare dry gases like chlorine, sulfur dioxide, hydrogen chloride. They are also used in desiccator. Whereas dehydrating agents, they prepare substances like carbon monoxide, sugar, charcoal, etc. Drying agent represent physical change, dehydrating agent represent chemical change. Here some of them are dehydrating agents also, like phosphorus pentoxide, fused calcium chloride, calcium oxide, concentrated sulfuric acid. These are drying agents. You have seen some of them are hygroscopic substances also, like calcium oxide, phosphorus pentoxide, concentrated sulfuric acid. These are hygroscopic substances also. Now dehydrating agent, you have concentrated sulfuric acid, again phosphorus pentoxide, as well as aluminium oxide also. These are some examples of dehydrating agent. If you add concentrated sulfuric acid in blue copper sulfate, you will get white copper sulfate and water. Whereas in case of sugar, if you add concentrated sulfuric acid, this is a part of class 10 again, you will get black carbon and water. So phosphorus pentoxide and aluminium oxide can also act as this dehydrating agent. Now gases can be dried by passing the gases through concentrated sulfuric acid, as it has very strong affinity for water. Gases which are generally acidic, like hydrogen chloride gas, those can be dried by concentrated sulfuric acid because there will be no reaction between those two acidic, because those two are in acidic nature. And you can also dry those by passing through dry tower or U-tube containing quicklime or anhydrous sodium sulfate. Quicklime, which is calcium oxide, can be used to dry ammonia gas, as both are basic in nature. Third option, if you pass it through a dry bulb containing anhydrous calcium chloride. Liquids are dried by keeping them overnight over anhydrous sodium sulfate or magnesium sulfate or calcium chloride at room temperature. The solid is then removed by filtration. Solid means these solids: anhydrous calcium chloride, magnesium sulfate or calcium chloride. Solids are generally dried by spreading those on watch glass. Watch glass is nothing, just a glass plate type, or a petri dish. Petri dish also is a glass plate with some border, and keeping them in a desiccator for some days. So these are certain items which we had discussed. This is desiccator. You have to keep the desiccant, that is anhydrous calcium chloride, in here. You can check up with your book also. This is generally a drying bottle containing concentrated sulfuric acid. You can see one side that moist gas is going in, bubble through, and the dry gas is going out. Then this is the drying tower. You can keep certain agent in this, drying agent. This is a U-tube. Again, you have to contain some drying agent or dehydrating agent over it. And this is the drying bulb. Thank you for your patience hearing.